with me all. Today I would like to present analysis of multi-panel simulation for each monocy and polycy and a differentiated area with various irradiance levels using ESCI. This is outline of presentation which includes 12 main parts. To introduce about my field, renewable energy is one of the major sources of power supply that abundantly generated the required electricity. Depend on renewable energy resources such as solar, wind, cited, geothermal, and biomass power for electrical power generation has begun in this decade. Solar generation stations are one of the correct solutions to support the electric grid without using traditional resources for generating electricity. Solar systems produce energy when exposed to sunlight without involvement of mechanical or moving parts. Therefore, photovoltaic power system is more preferable than other renewables. Here is the inner objective of my research: to provide photovoltaic module selection with better performance and various shading conditions in different irradiance levels. To show that the performance of multi-panel simulation for monocy is better than polycy and various shading patterns. In my abstract, different types of shading area are considered for monocy and polycy, which is connected in three-parallel configuration. The shading effects for PV array configuration are carried out with different irradiance values. For non-shaded condition, all modules of PV array will receive the equal irradiance value at the standard temperature condition. For shaded condition, the shaded module receives an equal amount of irradiance value such as 400, 600, 800 at 25 degrees C. The performance simulation results are carried out by using ESCI. This is the operation principle of PV cell. The photovoltaic cell contains N-type and P-type semiconductors separated by the PN junction. When the load is connected between the negative and positive sides of the cell, the electron flow as a current. More intense cell light gives a stronger current. If the light stops taking the cell, the current stops flow immediately. To extract mathematical model of solar PV module, we can use these equations. This figure shows the different shading pattern, the different shading area pattern. As you can see, no shaded area, 20% shaded area, 40% shaded area, 60% shaded area, 80% shaded area, and 100% shaded area are considered. This slide presents the simulation of solar PV module in ESCI. The solar PV module was modeled in ESCI as shown in figure. They are two inputs. They are irradiation and temperature. The irradiance and temperature are assumed at the standard condition 1000 watt per meter square and 25 degrees C. This table extracts the data for monocy and polycy when simulation in ESCI are used. After using the data from the previous slide and run the simulation in the ESCI, the PV and ADBC are coming out for each monocy and polycy. As you can see, the maximum output power for monocy is greater than polycy. And this slide shows the simulation results of 10x10 multi-panel by changing the load resistance from 1 ohm to 10 ohm and run the simulation, and then the results of maximum power are coming out for monocy with the different shaded area as you can see in the table. This slide shows voltage and current results for monocy with different shaded area. This slide expresses as a power, voltage, and current cap using the data from the previous slide. And then this slide shows the simulation result of 10 into 10 multiple net by changing the load resistance from 1 ohm to 10 ohm and run the simulation. Then the result of maximum power for policy are coming out with differentiated area, as you can see in the table. And this slide shows voltage and current result for policy with differentiated area. And this slide expresses as power, voltage, and current cap using the data from the previous slide. Finally, to be concluded, this paper has presented for each monocy and policy with the further differentiated area for various irradiance levels. The obtained result shows the maximum power generation, voltage, and current of differentiated area. Although the number of steps included in policy is twice that of monocy, the maximum output power is not better than monocy. Therefore, monocy is better than policy. And these are the reference that are used for my research. Thank you for your kind attention.
A very good afternoon to people gathered here. So we are going to present on the topic on a paper, a novel framework for COVID-19 diagnosis, combining UNET and CNN architecture. Here the presenters are Sai Swarupa, myself, and my co-authors Indumati and Priyanka. So this the table of contents goes as follows. The COVID-19 pandemic has led to an urgent need for efficient and accurate diagnosis system to detect positive cases and treat affected persons. So in this study, a weekly supervised active learning framework is proposed for the diagnosis of COVID-19 using CT scans. So the system utilizes a combination of 2D UNET and CNN along with a novel hybrid active learning strategy that considers predictor loss to improve accuracy. The system's efficiency and accuracy can contribute to the early COVID-19 detection and improve patients' outcome.
There are several existing methods for detecting COVID-19 in image processing, and the choice of method will depend on factors such as size and quality of the data set, the computational resources available for the specific requirements of the application. An important issue with the real-time RT-PCR test is the of electing false negative and false positive result. On the other hand, chest computed tomography is not precise as the RT-PCR test is detecting the virus, but may be more efficient and sensitive for clinical evaluation of SARS-CoV-2 pneumonia. The data preprocessing functionalities have issues in dealing with missing data, feature selection. Another problem is that MATLAB can only work with numerical data, and so categorical data will have to be converted in advance, and the techniques like decision trees.
And further moving on the proposed methodology, we are taking the input as CT scans. The data set used in this paper for COVID-19 diagnosis was obtained from the SARS-CoV-2 CT scan data set. CT is computed tomography, which is a medical imaging technique that uses X-rays and computer processing to create detailed images of body internal structures. CT scans are often preferred over traditional X-rays because they provide much more images and can capture structure that are not visible on X-rays. The CT scans were classified into two categories, COVID and non-COVID. Only human subjects who were deemed clinically appropriate for CT chest scans were included without considering age and gender. The SARS-CoV-2 CT scan dataset comprises 2,408.
So, as a part of pre-processing step, resizing is done with 128 cross 128 and denoising. Denoising is performed as next. Gaussian filtering is a common image processing technique used to smooth images by reducing noise and removing high-frequency components. It is based on the concept of convolving the image with a Gaussian kernel, which is a 2D bell-shaped function that assigns higher weights to the pixels closer to the center of the kernel and lower weights to the pixels farther away.
Histogram equalization image enhancement is the process of perfecting the visual quality of an image by conforming its colorful parameters, similarly as brightness, discrepancy, color balance, and softness. Here, histogram equalization is used the technique which is used in image processing to discrepancy of an image. It works by redistributing the intensity values of an image so that intensity values are more unevenly spread out over the entire range of possible values. This is achieved by calculating a histogram of the image and also applying a metamorphosis to the image that maps the intensity values to a new range. Histogram equalization can help to visual quality of the image and make it easier to price.
Image segmentation is the process of dividing an image into multiple regions or segments, each of which represents a distinct object of
The proposed architecture is 2D unit architecture is used to segment lung regions in each CT slice. The network's encoder leverages double convolutional layers and pooling layers to extract image features, which is performed in 4 stages of downsampling, resulting in a reduction of each slice to 1/16 of its original size. The decoder, on the other hand, uses 4 stages of upsampling and skip connections to concatenate feature maps from the same stage. Finally, the output layer generates a lung region mask that is the same size of the input CT slice. This method enables the segmentation network to learn lung region mask for each input CT slice using multi-scale image features.
A convolution neural type of deep active learning model used to analyze images and videos. In this classification, as mentioned, CNN is used to accurately differentiate between COVID and non-COVID cases based on the set of pre-processed input images. To perform this task, the CNN is supposed to extract local features from the input image by convolving a set of filters over the image. These filters are designed to identify specific patterns and features in the image, such as edges, curves. Next, a nonlinear activation function such as ReLU is applied to introduce nonlinearity in the network. This helps the network learn more complex and abstract using linear functions. The feature map generated by convolving downsampled using pooling operations such as max pooling. This reduces the spatial resolution of the feature maps while preserving the most important features. Finally, the extracted features are fed into the one or more fully connected layers for the classification task. These layers are used to extract features to classify the input image as either COVID or non-COVID.
In proposed methodology, to evaluate the overall performance of the working model, 5 parameters are used to calculate the results of the calculations, such as accuracy. This measures the percentage of correctly classified examples out of all the examples in the dataset. Specificity. This measures the percentage of correctly classified negative examples out of all the negative examples in the dataset. Sensitivity or recall. This measures the percentage of correctly classified positive examples out of the positive examples in the dataset. Precision. This measures the percentage of correctly classified positive examples out of all the examples classified as positive by the model. This is the harmonic mean of precision and recall. The training accuracy basically tells us how well the computer model is doing in predicting the correct outcome for the examples that is already seen and used for training. On the other hand, validation accuracy measures how well the model can predict the outcome for new examples that it is not seen during training. In order to achieve this, we usually set aside a part of our available data as the validation set and train for the model of the remaining data.
Accurate and timely diagnosis is crucial for controlling its spreads and treating. However, traditional diagnosis methods such as PCR tests have limitations in terms of cost, time, and availability. By leveraging the power of deep active learning, a COVID-19 diagnosis system can improve diagnosis accuracy and efficiency while reducing the cost and time. This technology can also enable early detection of COVID-19 and diagnosis.
So these were the key references we have referred.
Thank you for the wonderful opportunity.